Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. We are from group 4 that consists of me, Adariki, my friend Gifar Zulfajri, Akmal Taufikur Rahman, and Fahmi Ramadan. In this occasion, we will share about correlational research. What is correlational research? Correlational research refers to a non-experimental research method which studies the relationship between two variables with the help of statistical analysis. And this is type of correlation. First, positive correlation. It means both variables change in the same direction. As height increases, weight also increases. Then negative correlation. It means the variables change in opposite direction. As coffee consumption increases, tiredness decreases. Zero correlation. It means there is no relationship between the variables. Coffee consumption is not correlated with height. The first material will be delivered by Akmal.
Hello everyone, my name is Akmal Taufikur Rahman, and in this section I would like to talk about uses of correlational research and design of correlational studies. First, let's talk about the uses of correlational research. There are three uses of correlational research. First is assessing relationship. Second is assessing consistency. And third is prediction. Assessing the relationship. Correlational research methods are used to assess relationship and patterns of relationship amongst variables in a single group of a subject. Assessing consistency. Reliability or consistency of a test can be assessed through correlating tests or retests, equivalent form, or split half scores. Correlational can be used to measure consistency or lack thereof in a wide variety of cases. And finally, there are prediction. If you find two variables are correlated, then you can use one variable to predict the other. The higher the correlational, the more accurate the prediction. Prediction studies are frequently used in education. Next, let's talk about the correlational studies. The basic design for correlational research is straightforward. The researcher specifically the problem by asking the question about the relationship between variables of interest. The variables selected for investigation are generally based on theory. Previously researched, or researchers' observation. The population of interest also identified at this time. In simple correlational study, the researcher focused on gathering data on two or more measures from a single group subject. The next topic will be presented by my partner.
Alright, Bismillahirrahmanirrahim. Hello everyone, my name is Fahmi Ramadan, and here I will continue to explain the material in correlational research, which is the coefficients of the correlations. These coefficients of correlation have different kinds of coefficient in it that can be divided into two major kinds. The first is the scale of the measurements of the measures used, and the second is the number of variables. And here we will discuss about four kinds of the coefficients. The first is the Pearson product moment coefficients, and then the coefficient of determinations, and then the Spearman rho coefficient, and the last is the phi coefficients. Alright, for the Pearson product moment, it is a most widely used descriptive statistics of correlations. It is very appropriate for use when the data of the research are normally distributed and measured on an interval or ratio scales. And then the coefficients of determination. The coefficients of determination is a correlations that indicates percentage of relationship. For the example, this coefficient of determinations means the two variables, the percentage of two variables is related. This absolute size of coefficient determinations is the strength of the relationship. As we can see in the PowerPoint, there is an illustration for this the coefficient of determinations. The middle one, the part of the two variables, is the relations, the strength of relation between two variables. Next is the Spearman rho coefficients. Is it an ordinal coefficient of correlations used when the data are ranked? As we can see, the rho correlation of Spearman plus 1 for the same rank in the correlation, and minus 1 if the variables is opposite for each other, and then 0 if there is no relationship between the rankings. And the last is the p coefficients. Is it used when both variables are genuine dichotomies, core 1 or 0?
Hello, good morning. My name is Gifar Julpajri. On this occasion, I will explain about the consideration for interpreting a correlation coefficient. The important things of the numerical value of a particular correlation might be evaluated in four ways. Number one is considering the nature and its population and the shape of its distribution. Number two is a relation to other correlation of the same or similar variables. Number three, according to the absolute size and its predictive validity. Or number four is term of statistical significance. And move to the nature of the population and the shape of distribution. The value of an observed correlation is influenced by the characteristic of the population in which it is observed. A mathematical aptitude test that has a high correlation with subsequent math grades in a regular class, where the student ranks widely on both variables, would have a low correlation in a gifted class. This is because the math aptitude score in the gifted class are range restricted compared to those in a regular class. And then the comparison to other correlation. A useful correlation is one of higher than other correlation of the same or similar variable to the practical utility. If you want to avoid the significant fallacy, the assumption that a statistical significant correlation also has practical significance, a predictor with a high correlation that is difficult and expensive to obtain may be of less practical value than a cheap and easy predictor with a lower correlation. Also, note that a correlation coefficient only describes the degree of relationship between given operational definition of predictor and predicted the variables in a particular research situation for a given sample of subject. It can be easy change in a value if the same variable are measured and correlated using different operation definition and have a different sample. And we move to the statistical significance. In evaluating the size of correlation, it is important to know the size of the sample on which the correlation is based. Without knowing the sample size, you do not know if the correlation could easily have occurred merely as a result of change or is likely to be an indication of a genuine relationship. To avoid the error inferring a relationship in the population that does not really exist, the researchers should state the null hypothesis that the population correlation equal and then determine whether the obtained sample correlation departs sufficient from zero to justify the rejection of the null hypothesis. And then determining sample size. The person-product moment correlation is a form of effect size. Therefore, table R3 in the appendix can be used to determine the needed sample size for a predetermined level of significance and predetermined tolerance probability of type I error. For example, a researcher developed a measure of how much a person is willing to sacrifice to achieve success and found it had a very satisfactory reliability when administered to high school senior. Then we move to the correlation and causation. One of the most common errors made when analyzing a correlational research is misinterpreting a correlation as showing a cause and effect connection. For example, if a significant positive correlation is found between the number of hours of television watched per week and above average body weight among middle school pupils, that does not prove that excessive television watching causes obesity. Then move to the partial correlation. The partial correlation is a technique used to determine what correlation remains between two variables when the effect of another variable is eliminated. We know that the correlation between two variables may occur because both of them are correlated with a third variable. The partial correlation control for this third variable. And for the last is multiple regression. A multiple regression is a correlational procedure that examines the relationship among several variables. Specifically, this technique enables researchers to find the best possible weighting of two or more independent variables to yield a maximum correlation with a single dependent variable. In the development of a multiple regression equation, the variable should be measured on an interval scale, and it is possible. Thank you very much for your attention. Maybe it's enough from me. I give it back to moderator.
Okay, my name is Erika Filuswanika. My ID number 182122 On this occasion, I would like to explain about confirmatory factor analysis, or which can call CFA. According to Spacer 2005, confirmatory factor analysis is a family of techniques used to detect patterns in a test of interval level variables. Confirmatory factor analysis is known as a statistical tool that is useful in finding the form of construct from a set of manifest variable or testing a variable on the manifest assumption that build it. In the process of quantitative research, which is often by researchers in social and science disciplines, the most difficult stage after successfully formulating a framework of thought is the stage of measuring or personalizing research variables. This stage in the research process functions as a link that connects deductive thinking patterns to inductive thinking patterns. So the operationalization of variables. Research hypotheses are transformed into data where analysis and hypotheses were tested. Thus, in research based on a quantitative approach, the variable measurement stage are very important in determining the success or failure of a research to explain a phenomenon. Okay, that's enough for me. Thank you.
Other complex correlational procedure. Several more complex techniques are available to investigate correlation of more than two variables. These analyses require more sophistication with statistics than is usually needed and in a beginning research course. We briefly describe these techniques and refer interested students to other texts. Canonical correlation is a generalization of multiple regression that adds more than one dependent variable or criterion to the prediction equation. For more information on canonical correlation, see Thompson in 1984. Discriminant analysis is a statistical procedure related to multiple regression, but it differs in that the criterion is a categorical variable rather than a continuous one. A good source for this procedure is Haberty in 1994. Structural equation modeling, or SEM, is a popular technique used in the analysis of causality. SEM combines confirmatory factor analysis and path analysis to test both a measurement model and a structural model. We refer the reader to Bendler and Chow in 1988, Pederser in 2006, and Loh Lane 2004 for further discussion of SEM. Pederser in 2006 defines path analysis as a method for studying direct and indirect effects of variables hypothesized as causes of variables treated as effects. Pederser further states, path analysis is intended not to discover causes, but to shed light on the tenability of the causal models a researcher formulates based on knowledge and theoretical consideration. Page 769. That's all the materials that we can share. This is our references. Just text the question if you have. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.